Hello! Today we're going to be covering 10.2, which is all about cube root functions. So in lesson 10.1, we did square root functions, and now we're going to be doing cube roots, okay? So similar to what we did yesterday, really pretty much the same lesson, other than we're going to be doing the cube root. So what I'd like to do is grab my graphing calculator here, and let's just see what a cube root graph looks like. So we're going to go math, and then choose cube root, and then put an X in there, and then we'll go ahead and hit graph. You can kind of see it coming along the bottom, and then it turns, and then it goes like this. Okay? So the cube root is kind of an interesting function. Let me just kind of draw a little graph here. So it kind of comes flat along here, and then it goes up, and then it goes like this as well. Okay? Now, let me show you in Desmos, because in the graphing calculator, it's harder to manipulate and change it a lot. But if you notice right here, they're going to ask us for the domain and range. So let me show you in Desmos. So this is what the cube root looks like. Now, what I want you to see is if I zoom out, do you see how clearly the x's are still getting bigger? Now look at your y's. Do you notice how the y isn't really increasing that much, correct? But if we just keep going, I mean, it is going out. Now these are going now by 50. So this first y is a 50, 100. So it is going to keep increasing, but it's just going really, really slow. So it's very, very slow moving. See, look, 1, then 2, and then it's going to take a while to even get to a 3. So when we talk about domain and range, cube roots are actually easy, but the y can be sometimes kind of tricky to understand with the parent. So let's just quick do the domain. The domain would be our x's, which is really easy because it's just all real numbers. And actually, the range is also all real numbers because even though this looks like it's flat, it is still increasing just very, very slowly. So you should love the domain and range for cube root functions, okay? Now this again is often what they call the parent. So all they're going to do, the same thing as we've been doing in previous chapters in chapter 8 and in 10.1, is they're going to change the graph and just ask you how does this affect it. So they want you to graph it, they want you to compare it, and they want you to state the domain and range. So let's go down here and let's do that. Notice the -3 is underneath. Now again, if you're not sure, you can grab your graphing calculator and you can go to your y equals and let's go underneath and go -3. Now we already know from what we did yesterday that anything under is horizontal, and we also know anything under is the opposite. So this should be moving right 3. So let's see where it takes that turn. There it goes. Do you see how at +3 is where it took its turn? So if I were to graph this, at +3 right there is where this thing is going to kind of do its little curve like that. Now, that is really our comparison. So we've already said it. It's a horizontal translation because it moved horizontally and it moved right 3. Now notice that really doesn't affect our domain and range. Yeah, it shifted, but we're still covering 2, 1, 0, negative. We're still covering 3, 4, 5, 6, 7. So our domain and our range do not change. So those are kind of freebies. I mean, if you wanted, you really could just go through and do your domain and your range for all of them because again, they're kind of free ones. So let's take a look at this next one. We've got a +2 out in the back. Remember, anything outside is going to be vertical. And when we're vertical, it just is what it is. You don't have to do the opposite or anything like that. So I'm going to do +2. So right now, we should know that this is going to shift up 2, and that's where it's going to take its turn. Okay, so let's go ahead and graph that. Now notice my graphs aren't perfect. If you don't have graph paper at home, that's no big deal. Just kind of draw yourself a little rough sketch. So we know it's going to shift right there, so we'll just kind of go here, it goes, and then it changes. Now again, I'm not going to put a protractor on this, but notice from our picture that it's fairly flat. It does have a little slope to it. It does have a little curve to it, but it's not real steep. It's not a real high one. So just kind of sketch it in. And then we've already really set our comparison. This is outside, so that's going to be vertically up 2. And make sure you're using the proper vocabulary, so vertical and horizontal. Don't just say right, don't just say up, make sure you're using the correct vocabulary. All right, number 3. We've seen this negative before, so we should know what this is going to be. So we could do our comparison right now without even graphing it. The negative on the outside is a reflection over the x-axis. A negative on the inside is a reflection over the y-axis. And then a 4 on the outside we know is going to be a vertical. And notice this is outside and it's multiplied, so that's a vertical stretch of 4. And then we can do our domain and our range, okay? So let's just take a quick look at the graph so that we can sketch this properly. So let's clear this out and we'll go -4 cube roots of x. Now look what's happening. Do you see how it's making it taller? Okay, do you see how it's instead of it being flat, it's stretched it vertically? Now the graphing calculator, we don't really quite understand this part. I think we think we have an idea, but it's because the 0. So if you were to plug 0 into this equation, so let's say you have x is 0. When you plug 0 in, the cube root of 0 is 0, and then 0 times -4 is 0. So this point does exist, but in the graphing calculator, it has this weird little gap. So if you have a graphing calculator at home, type that in and you'll see it. And again, we don't really 100% know why. I didn't make the graphing calculator, but the only thing I can tell you is that I've seen it before. So we still know this point exists because we know 0, 0, it works when we plug it in. It's just showing that gap. But now we just need to do the -4. So remember, if this was the parent, so this was the original cube root of x, you're going to flip it. So you're going to flip it over. So it's going to go this way now, like that. See how we flipped it? So this would be the negative part to it. And then you're going to take this and you're going to stretch it. So we're just going to kind of go taller and then down and then like that. So this would be our -4, flipped or reflected and stretched cube roots of x, okay? Now, if you notice the last 3, which these are the only 3 we have, that's all of today's lesson, notice they just have more parts to them. So if you'd like to pause the video here and try these on your own, you can. Just know that this first one is a little tricky because of the horizontal. All right, hopefully you tried it. Or you at least took a quick look at it. We have this negative again, but now the negative is under. So now we're going to have a reflection over the y-axis. But I want you to think about that for a second. If you have a graph that looks like this, and here's your x-axis. When you reflect this over the x-axis, it's actually this part is going to come down here, and this part is going to go up there, like this. That's the reflection over the x-axis. But watch what happens when we reflect it over the y-axis. So think about the y-axis. You're going to take this arch and you're going to reflect it this way. You're going to take this one and reflect it this way. So if you reflect over the x or you reflect over the y, can you really tell the difference? No. So the drawings or the graphs look the same when you have the negative, but you need to make sure you're specifying which axis you reflect over, okay? So right now, if I were to just draw a rough sketch, I've got my parent, Okay, so there's the parent. I'm going to do a reflection, so it's going to look like this. So I don't have this one anymore. Okay, so there's my reflection. That's just my negative part underneath. But it really doesn't matter that it's under, because under and outside would look the same. Now the 6 is the tricky part. 6 is horizontal. We know that because it's under, but it's being multiplied. So it's either a stretch or a shrink. But you have to remember from your chart, if you go back to the chart from yesterday, that this needs to do the reciprocal. So if you take the reciprocal, it's a fraction. The reciprocal of 6 would be 1/6. So that means that this is a shrink of 1/6. Okay? Now these ones are also tricky because shrinks typically make you go flatter. But what happens in this is actually it does get taller. So I'll show you that in Desmos in just a second. So we're going to make this a little taller, and then notice we have the -2. So that's going to go vertically down 2. And I can just quick fill in my domain and range. Okay, so let me just show you. So the 6 now is actually going to make you be taller. So you're going to kind of look like that. That's going to be from the 6. And then the 2 is just going to take this dot and shift you down 1, 2. So now your dot, let me maybe do it in this hot pink because it might show up a little better. You're going to have your new like turning point be right there. And so it's just going to be a little taller, and then it'll turn, and then it'll go out like that. Okay? These are just rough sketches. They don't have to be spot on. Just you want to show the teacher or whoever's looking at your graph that you know the difference between a stretch and a shrink. Now let me go back to Desmos for just a second here. In Desmos, you can see I have the original graph, the parent. And then what I've done is I've put an A. So let me show you the A that is outside, actually. Let me change this, and I'll put the A outside like that. So the A outside is going to be a vertical stretch. So let me show you if it gets larger. See how it's going up? Watch if A is a fraction. So now I'm going to try to go smaller than 1. So do you see how it's getting flatter? Okay. Now watch if I change the A to be under. So if I change the A under, so at 1, it's right there. There's the original. Now, this is under. Do you see how, say, a 3, there's a 3, we would actually call that the reciprocal. So we would call this a shrink, but do you see how it's actually still getting taller? So the one we just had was a -6. So let me go to the negative. Watch it flip. Do you see how it flipped? Now I'll go to a -6. Do you see how it got taller? Okay, so horizontals can be very tricky because you have to pronounce them based on the reciprocal. Only the graph is based on how it looks. So if this is above 1, it's going to look like a stretch, only it's going to be pronounced as a shrink. So horizontals are by far the worst ones, but just kind of keep practicing with them and you'll get better. Now, if you notice these last 2 do not have any of the horizontal stretches and shrinks, so if you want to pause it here and try those, I think these would be good practice. Okay, hopefully you tried this one. So we have the original, we have this cube root here, that's the parent. We're going to move, remember, right 1. We always do the opposites. We're going to move right 1, and we're going to move up 1. So here's the new spot. So our new spot is right there, and then we don't do any stretch or shrinks. So it's just kind of the same curve to it. And that would be our comparison. Horizontal, right 1, and vertically up 1. Now remember, that actually does not change our domain and range. That stays the same because it doesn't matter. We're still covering 0, negative, 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 positive, positive, positive. So that will not affect it. So I could go over here and just fill these in right now, not even having looked at that part. Okay, so that's the one really positive to cube roots. Okay, cube roots here, number 6, 1/5. It's outside, so we know it's a vertical, and it's between 0 and 1, so that's going to be a shrink. Now remember, shrinks are going to make them flatter. So if you have the original, 1/5 now is just going to make it more inside, like this, like flatter. So that would be the 1/5 part, okay? +1 is really going to move it left. So that's going to be a horizontal translation, left 1. So now we've gone left 1, and the 4 is outside, and so that would be vertically up 4. So we'll move up 1, 2, 3, 4, and this is our new turning point. Now remember, this is going to be flat. If you try to do this on the graphing calculator, I guess 1/5 isn't too bad, but sometimes the smaller the fractions you have here, it can look really flat on the graphing calculator. So I've got x plus 1 and then plus 4. So let's watch that 1/5. See how it almost looks like it's a completely straight line? Every now and then you can see a little jump in it. But look when it crossed right there. You can barely see the turn right here. But it does kind of take that turn and it goes up just slightly. But look how flat that is. Because if you think about the decimal of 1/5, look at how, how close that is to 0. So that's a pretty flat line. And that concludes cube roots.